Welcome to the second part of our lesson involving the product rule and quotient rule. Now today we're going to be actually introducing and learning 4 additional derivatives of trigonometric functions. The other 4 trigonometric functions that we have not learned the derivatives of yet would be these 4. The tangent function, the cotangent function, the secant function, and the cosecant function. So the main objective for today is to learn what the derivatives of these are, so if I was working with them, I could find their slopes and the equations of tangent lines and other useful things that the derivative can tell us. And you might be wondering, why are we learning these right after we learned the product rule and quotient rule? In fact, they're in the same lesson here. Why did we learn the quotient rule and product rule yesterday, and now we're going to talk about the derivatives of these functions? Well, the reason is to prove what these derivatives are. We can avoid using the definition of the derivative, that is the limit definition, if we can use derivatives and rules that we already know. So we already know the derivatives for sine and cosine. And so one useful tool is to know how to write these 4 trigonometric functions using sine and cosine, such as you should know that a trigonometric identity for tangent x is to take the sine of x and divide it by the cosine of x. A trigonometric identity for cotangent x is to take the cosine of x and divide it by the sine of x. And maybe you're saying now, aha, now I know why we needed to know the quotient rule, because I can now differentiate the tangent function and cotangent function using the quotient rule. I've now got them written in terms of one function divided by another one. But we can also do that with secant x, because another way to write secant x is it's the reciprocal, or 1 over, the cosine function, and the cosecant x is also 1 over, or the reciprocal of the sine of x. So now that I've got these written this way, I can actually find the derivatives of the 4 functions on the left using the quotient rule applied to the expressions on the right. So if you're in class with me on Wednesday, the e-learning day for juniors, for sophomores, for freshmen and seniors, you will see us work out these proofs of what the 4 derivatives are. If you're doing this as e-learning, keep watching the video and we're going to work these out together. One thing that will come in handy for some of the proofs is a couple additional trigonometric identities. Pretty sure you would have had to have learned last year this trig identity right here. It's often called the Pythagorean trig identity. Sine squared x plus cosine squared x equals 1. And this can be used a number of different ways. It can be used just the way it is, but it can also be solved for other things. So for example, it could also be written sine squared x equals 1 minus cosine squared x. And it can also be written cosine squared x equals 1 minus sine squared x. So be ready to use any of those here as we go through the proofs of these other trigonometric functions. So for sure we needed to know these ways to write them, but it might come in simplifying their derivatives. I'm just going to say now it might come in handy that we know these trigonometric identities over here. Okay? So let's start with tangent and cotangent. So another way to say that we want the derivative of the tangent x function is to say that I want the derivative of the expression sine x over cosine x. And just similarly, I can also state the problem on the right as I want the derivative of the quotient cosine x over sine x. And now that I've got it written that way, this is the derivative of a quotient of 2 functions, so we can certainly use the quotient rule. And we learned the little rhyming scheme for this yesterday was low times the derivative of the high function, low d high, minus high d low, and then it's all over the square of what's below. I'm going to go ahead and write out my template, and then we're going to fill this in and see where this leads. Okay, so my rule says low d high minus high d low all over the square of what's below. So whenever I say low, we're talking about the cosine function. So here where it's low d high, it's cosine x, and then the derivative of sine x, which is also cosine x. Now on this side, it's supposed to be high d low, so it's going to be sine x times the derivative of cosine x, but the derivative of cosine x is negative sine x. And then it's all over the square of what's below, so it's all over cosine of x quantity squared. Okay, let's see what we've got. The upper left corner is cosine x times cosine x, so that's cosine of x cosine squared. I'm going to write it cosine squared. Then it's minus, but then it's sine x times negative sine x, so altogether it's minus negative sine squared. I'm going to go ahead and notice I've got a double negative now, so it's plus sine squared. And then it's all over cosine squared. Okay, now if you learned anything last year in proving some trigonometric identities, you probably understood that there's many ways you can rewrite a trigonometric expression. And there's really nothing wrong with this one. It's already kind of simple. It comes directly from the quotient rule. However, the numerator contains a very common trig identity. We already wrote it on the previous slide. It contains the expression cosine squared plus sine squared. And that is exactly the Pythagorean identity. So I can replace that whole expression with a 1. And that simplifies our derivative even further. So now my derivative of tangent x is 1 over cosine squared. Now, I've always preferred to write my derivatives not in the form of a fraction if I can avoid it. So my one last thing I'd like to do now is change, since I know that 1 over cosine is an identity for secant x, I want the final answer to this derivative to be secant squared x. So conclusion is the derivative of tangent x is secant squared x. If we were in class here, I would ask you now to try to prove this other derivative in the very same way. And if you want to pause the video and try that, I encourage you to do it. But if not, I'm going to fill it in now, and then you can see the result. Okay, so I went ahead and filled in my template for the quotient rule, where low, in the rhyme low d high minus high d low, the low is sine x and the high is cosine x. So here's low d high minus, here's high d low, and it's all over the square of what's below. And I went ahead and multiplied the upper corner and upper right corner and left corner together. So sine x times negative sine x is negative sine squared x. The upper right corner will be minus cosine squared x, and it's all over sine squared. Now this time I don't exactly have sine squared plus cosine squared, but if you look carefully, I kind of do, because both of these terms have a minus sign, so I can actually think of it as there's like a little invisible negative 1 in front of each of those. So if I were to factor out a common factor of minus 1, it actually looks like this. Negative 1 times the quantity sine squared plus cosine squared. And now I can replace all the parts in the parentheses with just the number 1 again. So it's going to be minus 1 over sine squared. And I'd like to do the same thing I did with the derivative of tangent x and replace 1 over sine squared with a trig identity cosecant squared. And so the derivative of cotangent x, we will write it as the negative cosecant squared function. Okay, so it's kind of like with sine and cosine in that there's kind of a pattern to these. They're both a trigonometric function squared. They're both the co-function of the other one, right? So there's secant and there's cosecant. And one of the derivatives has no negative sign in the answer, and one of them has a negative sign in the answer. So in that way, there's similar patterns to the derivative of sine and cosine. Well, let's try this again with secant and cosecant. So on this one, for secant x, we will treat this like we want the derivative of 1 over cosine. And for cosecant, we're going to treat it like we want the derivative of 1 over sine x. And once again, we're going to use the quotient rule. I'm going to work out in great detail the first one, and I would suggest you pause the video and try to work out the second one yourself. So whenever I say low, we're talking about cosine x. Whenever I say high, we're talking about 1. Okay, so when I go low d high, it's cosine x times the derivative of 1, but the derivative of 1 is 0 because it's a constant, minus high d low, 1 times the derivative of cosine, which is negative sine x. And then it's all over square of what's below, so it's all over cosine squared. Now, so what I've got left now is nothing here, that's 0. I've got a minus and then another negative, so this is going to be a positive sine x over cosine squared. Okay, so we could say this is already good because A, it's all in terms of sines and cosines. There's no negatives or anything to worry about. And there's no obvious trigonometric identities to use. However, I would like the answer to this to be the same format as the first two, and that is I would like to find a way to not write this as a fraction. So to do that, I'm going to expand out the denominator a little bit and write it as cosine x times cosine x. And I would also like to write sine x as sine x times 1. So now I can regroup these into two fractions. One of them is going to be 1 over cosine. 1 over cosine. The other one is going to be sine over cosine. And they would multiply together, right? So 1 over cosine x is an identity for secant x. And sine x divided by cosine x is an identity for tangent x. So now I would write my derivative of secant x as secant x times tangent x. That is the way it's normally written. Okay, now sine over cosine squared is not wrong. It's just this is the traditional way we're going to write it. And then if we write the other derivative in a similar way, you'll see that there's a pattern to this too. In fact, now that you've seen me do 3 of these today, maybe you can predict what this one is going to be. I encourage you to pause the video and try it yourself, but I'm going to work it out in just a second here. Okay, I'm back, and I've worked out my quotient rule for the derivative of 1 over sine x, which is the derivative of cosecant x. So here's my rule. Low d high, sine x times 0, minus high d low, 1 times cosine x. And it's all over the square of what's below. It's all over sine squared x. So simplifying the numerator, the upper left corner would just all be 0. And I'm left with negative 1 cosine x all over sine squared x. And to help me write it like the other one, I'm going to write the numerator as negative 1 times cosine x. And the denominator as sine x times sine x. And then kind of regroup this into two fractions. One of them will be negative 1 over sine x, which is negative cosecant x. And then I've got the fraction cosine x over sine x, which is an identity for cotangent x. And now I'm going to leave that as my derivative. So notice the secant function had a derivative secant x tangent x. Notice that secant x is in its own derivative. And the cosecant function has itself in the derivative, but also the cotangent function. And there's a minus sign. So let's now summarize the 4 we've worked out today, and I'm going to pencil them in here, and then we're going to look at the pattern a little more closely. So the tangent function's derivative, that one was secant squared. The derivative of the cotangent was negative cosecant squared. The derivative of secant x was secant x times tangent x. And the derivative of the cosecant was negative cosecant x times cotangent x. Now underneath, I'm going to put the two we learned previously. So on this side, I'm going to put the derivative of sine x. And we learned that was a cosine of x. And on this side, we have the derivative of cosine x is sine x. There's a couple of important patterns in this list. The first one is kind of just side to side. Okay, so like the derivative of sine was cosine, and the derivative of cosine was sine. So we notice the use of co-functions there. The derivatives of tangent and cotangent also involved co-functions, secant squared and then cosecant squared. And then noticing that the one on the right had a negative sign. Derivative of secant x was secant x times tangent x. The derivative of the cosecant involved the co-functions of those, negative cosecant x and cotangent x. So that's a useful pattern, thinking about going from left to right on each of these rows. Now the other important item here is to notice that 3 of these derivatives have negatives in their derivatives and 3 of them do not. So it's important you understand how to know which ones are the negatives and which ones are not. One thing that helped me over these years is to notice that all the ones on the right side are co-functions. The derivative of cotangent, the derivative of cosecant, and the derivative of cosine all have the negative signs in their derivatives. So all the co-functions have negatives in their derivatives. The other ones do not. Okay. There's going to be a second video now where we'll practice using these differentiation rules a little bit.